66 million years in the past, our planet experienced a cataclysmic event that would forever alter the course of life. This was not a single day as we perceive it, but rather an epical turning point in the grand tapestry of Earth's history. Imagine a world where dinosaurs, those colossal titans of the Mesozoic era, reigned supreme over every continent, unchallenged for 160 million years. Picture a planet where predators the size of buses relentlessly pursued herds of horned behemoths across the vast, sunlit expanses of the late Cretaceous plains. Yet, in a span of time so brief in geological terms, all this grand a celestial stone, a mere 12 kilometers in diameter, descended from the cosmos, transforming a thriving biosphere into a charred wasteland. This was not a mere metaphor, but a stark reality. However, the true horror lay not in the impact itself, but in the chain of events that unfolded in the subsequent hours, days, and years. To grasp the magnitude of this disaster, one must first understand the world just moments before the asteroid's descent upon the Yucatan Peninsula, in what is now Mexico. The end of the Cretaceous period was a time of extraordinary biological diversity, with over 1,000 species of dinosaurs alone inhabiting the planet. Tyrannosaurus rex roamed what is now Montana, while Triceratops grazed in herds of hundreds, and pteranodons soared over warm seas. In the oceans, enormous mosasaurs, some reaching lengths of 18 meters, dominated the waters, preying on everything from sharks to car-sized sea turtles. The climate was markedly different from today, with average temperatures 4 degrees Celsius higher. Polar ice caps were non-existent, and forests thrived even in regions that are now the icy expanse of Antarctica. This was a world devoid of winter as we know it, a world of abundance and warmth, where evolution crafted new life forms with astonishing speed. Into this vibrant world hurtled the asteroid, later named Chicxulub by scientists. Traveling at a velocity of 20 kilometers per second, 72,000 kilometers per hour, it was 60 times faster than a bullet fired from a sniper rifle. The energy released upon impact was equivalent to 100 million megatons of TNT, akin to 10 billion Hiroshima bombs detonating simultaneously. But before delving into the details of the impact, one must consider the origins of this cosmic assailant and why Earth became its target. The Chicxulub asteroid belonged to the class of carbonaceous chondrites, ancient remnants of the primordial protoplanetary disk, relics from the formation of the solar system 4 billion years ago. According to one hypothesis, gravitational perturbations from Jupiter ejected this fragment from the asteroid belt between Mars and Jupiter, setting it on a collision course with Earth. In this cosmic ballet, a single event reshaped the destiny of life, reminding us of the delicate balance that sustains our existence. As we reflect on this ancient catastrophe, we ponder the resilience of life and the ever-present potential for renewal and transformation in the face of adversity. A compelling theory suggests that the Chicxulub impactor was once a fragment of a larger celestial body, shattered by a collision in the asteroid belt approximately 160 million years before it would herald the end of an era on Earth. Regardless of its origin, this cosmic wanderer traversed the vastness of space for eons, an unknowing harbinger of doom for all terrestrial life. Dinosaurs, oblivious to the impending cataclysm, gazed not at the heavens nor crafted telescopes to divine their fate, but simply carried on with the rhythms of their existence on what would be the final day of their dominion. The dawn of the last day of the Cretaceous period unfolded indistinguishably from countless others across the expanse of what is now Central America and the shores of the Gulf of Mexico. Herds of Edmontosaurus grazed peacefully on coastal plains, while pterosaurs skimmed the warm, shallow seas in search of sustenance. Tyrannosaurs slumbered contentedly in the shadow of towering conifers, sated from nocturnal hunt. As the asteroid breached Earth's atmosphere, transforming into a blinding fireball, outshining 1,000 suns. Mere moments before impact, the air before this celestial missile heated to an unimaginable 60,000 degrees, tenfold the surface temperature of the Sun, glowing with an intense white light. Envision the ignition of a second sun overhead. Yet this one did not warm. It incinerated everything within hundreds of kilometers instantaneously. Upon contact with Earth's surface, the asteroid struck the shallow Yucatan Shelf, where the sea was a mere 200 meters deep above a limestone bed. The impact penetrated Earth's crust to a depth of 30 kilometers in fractions of a second, forming a transient cavity nearly 100 kilometers wide, which began to collapse immediately. The analogy is akin to casting a stone into water, except the medium was solid rock, and the stone was a cosmic projectile weighing 1 trillion tons. The central peak of the crater surged skyward, reaching 10 kilometers, surpassing even Everest, before collapsing back, sculpting the final form of the Chicxulub crater. The crater spanned 180 kilometers in diameter, a scar now hidden beneath sediment, discernible only through gravimetric instruments. Half lies on the Yucatan Peninsula, while the other half is submerged beneath the Gulf of Mexico's waters, a cosmic mark etched upon Earth's visage. Yet the crater was but the beginning, as true devastation unfolded not merely at the point of impact, but across thousands of kilometers in the ensuing minutes and hours. Within the first 10 seconds post-impact, a shockwave radiated at the speed of sound, obliterating all life within 1,000 kilometers of the epicenter, akin to an unprecedented hurricane. The seismic force unleashed by the impact registered at an estimated magnitude of 11 on the Richter scale, 1,000-fold more potent than any earthquake recorded in human history. This moment, this collision of cosmic and terrestrial forces, was not merely an end, but a profound reordering of life on Earth, a reminder of the delicate balance upon which existence is poised and the inexorable march of time that shapes the destiny of worlds. Seismic waves traversed the globe, encircling it multiple times, with a force that awakened slumbering giants beneath the Earth's crust. Volcanoes erupted in fury, landslides cascaded down mountainsides, and tectonic plates shifted violently, sending tremors through the very bones of the planet. These events unfolded tens of thousands of kilometers from the epicenter of a cataclysmic impact. On the shores of what is now Texas, approximately 1,500 kilometers from the epicenter, lies a site of remarkable significance known as Tanis. Here, the narrative of Earth's most dramatic chapter begins to unfold. In the year 2019, paleontologist Robert De Palma uncovered a graveyard at Tanis, a site where life was abruptly halted in the immediate aftermath of the Chicxulub asteroid impact. It is here that evidence of a world forever changed was preserved in haunting detail. Among the findings were fish with glassy spheres, known as tektites, lodged in their gills. These tektites rained from the heavens a mere 15 minutes after the asteroid's collision with Earth. Formed from molten rock propelled into the upper atmosphere and beyond, these fiery droplets returned to the surface, igniting the landscape and wreaking havoc on all exposed to their infernal descent. Imagine, if you will, a deluge of molten glass descending from the sky at hundreds of kilometers per hour. This scalding rain set forests ablaze and spelled doom for countless creatures caught in the open. The fish, still alive as the tektites choked their gills, were then entombed forever beneath layers of sediment by a massive seiche wave, a colossal surge of water triggered by the impact, sweeping through nearby bodies of water. Nearby, a dinosaur's leg belonging to a Thescelosaurus was discovered, severed perhaps by the force of rushing water or debris. The preservation was so extraordinary that even the scales on the limb remained visible, offering an eerie glimpse into a lost world. Tanis stands as a veritable time machine, allowing scientists to reconstruct the final day of the Cretaceous with remarkable precision, down to the very minute. The vision that emerges is one of unimaginable destruction, far more severe than previously conceived. The asteroid's impact was not a mere stroke of misfortune upon any random location. It struck a region rich in limestone and anhydrite, deposits laden with sulfur. This proved to be the catalyst for a global catastrophe. Had the Chicxulub asteroid plunged into the open ocean or struck a granite shield, the consequences, though dire, might have allowed dinosaurs to persist as a species on our planet. Yet, fate chose a different path. The impact unleashed approximately 300 billion tons of sulfur into the atmosphere, transforming into a veil of sulfuric acid aerosols. It was as though every volcano on Earth had erupted simultaneously, augmented by a planetary-scale chemical weapon that poisoned the air for decades. Researchers from the Potsdam Institute for Climate Impact Research calculated the odds of the asteroid striking such sulfur-rich deposits at a mere 13% of Earth's surface. It was a cosmic gamble, and the dinosaurs found themselves on the losing end of this celestial roulette. In the aftermath, a second act of devastation unfolded. Not from the Earth, but from the sky. The ejected material began its return journey, re-entering the atmosphere as incandescent spheres. Within an hour, the heavens above the entire planet were set ablaze, sealing the fate of 75% of all species in a fiery conclusion. Infrared radiation emitted by the plummeting tektites heated the upper layers of the atmosphere to several hundred degrees Celsius, igniting a global forest fire of unimaginable ferocity upon the Earth's surface. In the aftermath of the impact, computer models reveal that air temperatures near the surface soared to 200 degrees Celsius, extending thousands of kilometers from the impact. Everything combustible erupted into flames simultaneously across millions of square kilometers, and the resultant smoke ascended into the stratosphere, casting a shadow that obscured sunlight for months. Scientists estimate that approximately 70% of the world's forests were consumed, releasing 15 billion tons of pure carbon into the atmosphere. To put this into perspective, this single catastrophic day, 66 million years ago, generated 1,000 times more soot than all the wildfires on Earth in the past century combined. Yet the infernos were merely the prelude to a far greater nemesis, which wielded its devastation not through fire or water, but through silence and cold, descending in the ensuing weeks. The soot and sulfur aerosols in the stratosphere blocked up to 90% of sunlight, ushering in what is known as an impact winter, lasting for several years. Envision a world where the sun fails to rise, temperatures plummet 25 degrees below normal, and photosynthesis grinds to a near halt across the globe. Deprived of sunlight, plants began to perish with. The oceans suffered equally, as phytoplankton, the foundation of the marine food web, perished almost entirely. Ammonites and belemnites dissolved coral reefs and poisoned freshwater bodies worldwide for many years. Researchers from the University of Texas at Austin, examining core samples from the Chicxulub crater, discovered that the ocean in the impact region remained lifeless for approximately 30,000 years post-catastrophe. This was the weapon of silence. Externally, the planet appeared almost normal within a few years, yet internally, ecosystems were left as barren voids, filling with life at an agonizingly slow pace. But the asteroid was not the sole harbinger of the Cretaceous period's end, for something equally monumental unfolded thousands of kilometers from Yucatan. In what is now modern-day India, the Deccan Traps erupted throughout the last 500,000 years of the Cretaceous period, with a scale of volcanic activity that defies imagination. The Deccan Traps disgorged approximately 1.5 million cubic kilometers of basaltic lava, blanketing an area of 500,000 square kilometers with layers up to 2 kilometers thick. This relentless volcanic activity spewed vast amounts of volcanic gases into the atmosphere, contributing further to the environmental upheaval. Together, these cataclysmic events forged a world where life teetered on the brink of annihilation. Yet, from the ashes of devastation, life found a way to endure and adapt, a testament to the resilience and tenacity of life itself. The Earth, once a near-silent void, gradually stirred with the whispers of new beginnings, reminding us of the delicate balance upon which our existence rests. In a time long before humanity's dominion, a geological cataclysm unfolded with a ferocity that would forever alter the course of life on Earth. The Deccan Traps, a vast volcanic province in what is now India, erupted with a force unparalleled, spewing forth enough lava to fill the Black Sea entirely and still have a surplus to cover France with a layer several meters thick. This monumental volcanic activity unleashed vast quantities of carbon dioxide and sulfur into the atmosphere, triggering climatic upheavals that predated the catastrophic impact of the asteroid on the Yucatan Peninsula. Among the scientific community, a debate rages on regarding the true architect of the mass extinction that marked the end of the Cretaceous period. Paleontologist Gerta Keller from Princeton University posits that the relentless volcanism was the primary driver of this extinction event, weakening ecosystems to a critical point, while the asteroid impact merely delivered the final fatal blow. Conversely, researchers such as Paul Wren's team from the University of California, Berkeley, argue that the asteroid's collision intensified the Deccan eruptions through seismic waves, amplifying their ferocity 2 to 3-fold in the immediate aftermath. It was as if the asteroid had shaken the Earth so violently that it squeezed out the remaining magma from its depths. This paints a harrowing picture of a double-edged assault on life. For hundreds of thousands of years, volcanic activity destabilized ecosystems, setting the stage for an asteroid to deliver a coup de grace. It was akin to a scenario where a patient, slowly poisoned over time, is finally struck down with a sledgehammer. Each factor alone might not have sufficed, but together, volcanism and the asteroid impact conspired to create a perfect storm, extinguishing 3/4 of all species on the planet, and irrevocably redrawing the map of life on Earth. Reflect for a moment. In the past 500 million years, Earth has witnessed 5 mass extinctions. Yet none were as abrupt and devastating as this. The Permian extinction, 252 million years ago, eradicated 96% of marine species, but unfolded over tens of thousands of years. In stark contrast, the Cretaceous Paleogene extinction struck with a swiftness that, geologically speaking, was but a blink of an eye, its main devastation occurring within hours to a few years. Amidst this inferno, who were the survivors, and why did some creatures endure while others vanished without a trace? The answers lie in a confluence of factors: body size, dietary habits, and the ability to seek refuge. Smaller creatures fared significantly better than their larger counterparts. Every terrestrial animal exceeding 25 kilograms met its demise, signaling the abrupt end of the age of giants in a singular geological instant. Small mammals, akin to modern rats, survived by burrowing, sustaining themselves on seeds and insects and enduring the cold thanks to their endothermy and fur. Crocodiles endured due to their ability to survive for months without food, enter dormancy, and inhabit aquatic environments that retained heat longer than the frigid land. Turtles, too, survived for similar reasons. Their slow metabolism allowed them to remain motionless in the mud for months, waiting patiently for warmth to return. In this tale of destruction and survival, we find a poignant reflection of the resilience and fragility of life. The smallest and most adaptable creatures, through their unassuming tenacity, inherited a world reshaped by fire and ice, a testament to the enduring power of life's will to persist against the odds. Birds, the descendants of small theropods, owe their survival to their diminutive size, their capacity to fly to distant food sources, and their ability to subsist on seeds that could remain viable in the soil for years. Intriguingly, the avian species that dwelled in trees vanished along with the forests, leaving only the ground-dwelling birds to survive. From these terrestrial ancestors, the vast diversity of modern avian life would eventually flourish. In the oceans, it was the deep-sea organisms that endured, subsisting on detritus, organic matter descending from above. This rain of dead organic material persisted even during the harshest periods of the impact winter. Sharks, with their broad dietary adaptability and slow metabolism, proved resilient. These versatile predators could sustain themselves on carrion, and easily switch between various food sources. Yet the ammonites, which have thrived in the seas for 350 million years, met their end. Their larvae were dependent on plankton, which was among the first to perish. Similarly, the mighty mosasaurs vanished, their massive bodies requiring more sustenance than the depleted environment could supply. Pterosaurs, which had graced the skies since the Triassic period for 160 million years, disappeared forever. The skies were left to the small, hardy birds of the Cretaceous period. For years, scientists debated whether dinosaurs perished instantaneously or dwindled over millions of years leading up to the asteroid's impact. Modern evidence suggests that dinosaurs were thriving until their abrupt extinction. New species were emerging and populations were stable and diverse across the globe. A 2021 study published in Nature Communications analyzing thousands of fossils found no signs of dinosaur decline prior to the catastrophe. This indicates that in the absence of the asteroid, dinosaurs might have continued to dominate the planet for tens of millions of years, potentially denying mammals the opportunity to rise from obscurity. Turning our gaze to the aftermath of the impact, the planet's recovery was as dramatic as its destruction. We're among the first to colonize the barren expanses, initiating what is known as the fern spike. Geologists discover this fern layer worldwide, a slender green band of life wedged between two layers of death, precisely at the Cretaceous-Paleogene boundary. Above the fern layer, the first flowering plant took anywhere from 1 to 10 million years. Mammals began to increase in size within 300,000 years after the catastrophe, rapidly occupying ecological niches vacated by the dinosaurs in a remarkable burst of evolutionary radiation. Thus, the story of life on Earth is one of resilience and adaptation, where the end of one era heralds the dawn of another. The fall of the mighty dinosaurs paved the way for mammals to ascend, illustrating the relentless and transformative power of nature's cycles. In the vast tapestry of Earth's history, a mere 10 million years after a cosmic event of cataclysmic proportions, mammals the size of bears began to roam the planet. Fast forward another 10 million years, and the first ancestors of whales and horses made their appearance. This evolutionary trajectory, however, was set in motion by a singular event, the extinction of the dinosaurs, a consequence of an asteroid impact 66 million years ago. The story of this extinction event begins with the discovery of the Chicxulub crater, unearthed not by paleontologists, but by geophysicists Glenn Penfield and Antonio Camargo in 1978. While searching for oil on the Yucatan Peninsula for a Mexican petroleum company, they encountered an unusual arc-shaped gravitational anomaly beneath the jungle and ocean floor. Yet their discovery was shrouded in secrecy, concealed by the oil company, and unpublished for a decade. Simultaneously, in a separate narrative thread, physicist Luis Alvarez and his geologist son Walter Alvarez, in 1980, identified an anomalously high concentration of iridium at the boundary between the Cretaceous and Paleogene periods. Iridium, a rare element on Earth's surface but abundant in asteroids, was found in a thin layer of clay in over 100 locations globally. This evidence laid the foundation for the Alvarez hypothesis, suggesting that an asteroid had caused the mass extinction event. Initially, their theory was met with fierce resistance from the scientific community, many of whom dismissed it as a fantastical notion. It took more than a decade of rigorous debate, field expeditions, and meticulous analyses before this asteroid hypothesis gained acceptance as the prevailing explanation for the Cretaceous-Paleogene extinction event. In 2016, an international expedition drilled directly into the peak ring of the Chicxulub crater, reaching 1,300 meters below the seabed. The core samples extracted revealed that granite rocks, typically found 10 kilometers deep, had been thrust to the surface and pulverized into fine sand almost instantaneously. This evidence demonstrated the unimaginable force of the impact, causing solid. This cataclysmic event also illuminates the fragility of life and the randomness of evolutionary paths. Had the asteroid arrived a mere 10 minutes earlier or later, it would have struck deep ocean waters, where the rocks contained far less sulfur, resulting in considerably milder consequences. Similarly, a more oblique angle of impact would have dissipated much of the energy in the atmosphere, significantly reducing the sulfur ejected into the stratosphere. Japanese researchers from Tohoku University calculated that an impact in the deep ocean would have resulted in insufficient soot to trigger a global impact winter. In this alternate scenario, the dinosaurs might have survived, relegating mammals to remain as small, nocturnal creatures, and the emergence of intelligent life on Earth. In contemplating these cosmic and terrestrial events, one is reminded of the delicate balance upon which life on our planet hinges, and how the serendipitous dance of celestial bodies has shaped the very essence of our existence. In the vast, indifferent cosmos, justice is a concept unrecognized. A stone, GDK through the void, found its destination 66 million years ago, and the world was irrevocably altered in the blink of an eye. This was no ordinary stone. It was an asteroid that collided with Earth, triggering a cascade of catastrophic events that reshaped the planet. In the aftermath of the impact, the Earth was plunged into a period of darkness and cold, known as the impact winter. Yet, this was only the beginning. For nearly 100, these volcanic eruptions spewed vast quantities of carbon dioxide into the atmosphere, leading to a greenhouse effect that countered the initial chill with a searing heat. The planet swung between extremes, a pendulum of ice and fire, each swing dealing a deadly blow to life on Earth. Those organisms that managed to endure the initial freeze were soon faced with relentless heat. The survivors of the heat wave found themselves in an increasingly acidic ocean, where the very shells of their prey were dissolving, eroding the base of the food chain. The Cretaceous seas, once teeming with life, saw a staggering 90% reduction in biomass. The recovery of marine ecosystems lagged significantly behind that of terrestrial ecosystems, as the oceans bore the brunt of the catastrophe. Coral reefs, the vibrant underwater cities, were devastated by acidic rain and the absence of sunlight, and they did not return for 2 million years after the Cretaceous-Paleogene boundary. Where thriving reefs once stood, now lay dead zones, expanses of ocean floor where sediments settled without any sign of life, etching a silent record of global devastation into the geological archive. Yet, life possesses a tenacious resilience, finding ways to thrive even after the most harrowing of cataclysms. In the wake of the dinosaurs' extinction, the stage was set for mammals, creatures that had long lived in the shadows of the colossal reptiles. For 160 million years, mammals had remained small, no larger than a modern-day cat. But with the giants gone, they emerged and evolved. A mere 5 million years after the asteroid's impact, the first large mammalian predators roamed the land, and the oceans witnessed the beginnings of cetacean evolution as land-dwelling hoofed creatures took to the seas. 15 million years later, the earliest primates swung through the trees, and 50 million years hence, one of their descendants would gaze skyward, pondering the stars. Today, the asteroid belt between Mars and Jupiter is a reminder of those cosmic forces, with millions of rocky fragments orbiting the Sun. Some of these objects occasionally cross paths with Earth, posing potential threats. NASA's Near-Earth Object Program has cataloged over 34,000 such objects, yet scientists acknowledge that many dangerous asteroids remain undetected. In 2022, the DART mission achieved a historic milestone by altering the trajectory of the asteroid Dimorphos, demonstrating humanity's growing capability to defend against cosmic threats. However, 66 million years ago, no such intervention was possible. An entire era of life was extinguished in the fleeting span of a meteor's flight across the night sky. On that fateful day, a Tyrannosaurus might have hunted a Triceratops in the morning, only to be rendered extinct by evening. The long arc of dinosaur evolution, spanning 160 million years, was reduced to a thin layer of clay, a testament to the fragility and endurance of life in the face of cosmic indifference. Each time a sparrow perches upon your windowsill, Remember that it is a living descendant of dinosaurs, the sole branch that survived the fiery and icy crucible of that fateful day. We exist today only because 66 million years ago, a small creature, no larger than a rat, burrowed into the earth, enduring the most terrifying of days. This tiny being could not have foreseen that its distant descendants would one day construct telescopes, journey into space, and locate the very crater that forever buried the realm of its ancient rulers. The Chicxulub asteroid obliterated an era of giants, yet paradoxically, it heralded the dawn of an age of intellect. The death of one world became the birth of another, and we, humans, stand as living testament to the astonishing truth that from the ashes of the greatest catastrophe can emerge something both remarkable and beautiful. This profound cycle underscores the resilience of life and the ceaseless march of evolution, where destruction begets creation in an eternal dance of the cosmos.